Hi, Julien. I believe we can get started now.
Okay, sure. Can you hear me properly? Yeah, okay, cool. So welcome everyone to this webinar. So today we are going to talk during an hour about some tips on how to build enterprise application on the blockchain. And yeah, so this webinar is brought to you by PegaSys and especially PegaSys Orchestrate. So I'm Julien Marchand. I'm a product manager at PegaSys, especially working on PegaSys Orchestrate. So prior to joining Consensus, I've been working at Ernst & Young, so EY, for about 3 years in the consultancy and development field. And then I've been working for a year at Consensus Solution, especially as a technical lead and an architect, and facing clients trying to design and build enterprise application for clients. And so basically this talk is about summarizing the challenges that we faced and what solution we have implemented. Yeah, so basically showing you the big picture of what we've seen. So you can find my email address and don't hesitate to follow us on Twitter, Gitter, and GitHub at PegaSys Engineering. So for the agenda, so we will start by having by explaining the context architecture. So by giving you an example of what enterprise application may look like and what services are inside it. Giving you then some technical reminders so that everyone is on the same page. Then moving on to the second section, we will talk about multiple pain points that we have faced and what are the solutions that we have implemented to face them. Starting with the security needs, then the no-fail environment. So basically making sure that your transaction and your flow never stops and can run properly, smoothly. And then what are the tips to handle high volume throughput on a given blockchain? This will lead us to the PegaSys Orchestrate presentation, which is basically a new product by PegaSys that try to address these challenges and bring a solution and some services that will face your challenges in an agnostic way. So going through the design of PegaSys Orchestrate, focusing on the main feature that we have, and then where does it stand in the PegaSys product picture. So first, a few friendly reminders. The mute is enforced, so you will not be able to speak. Please ask a question in the Q&A box. We will make some regular stop between sections so that you may ask your question in the chat. And then we will do a longer Q&A session at the end to discuss more in depth the question you may have. As a reminder, we are also recording this session, at least I hope, and we will share the materials and the recording at the end, along with the feedback form. So don't hesitate to reach out to us. So starting with the context architecture and a few technical reminders. So when trying to build an enterprise application platform, you will have to develop some, you will have 3 major components to build or interact with. The first one is the client-facing interfaces and APIs and front-end that will contain your functional flow. The second part is around building the services, the blockchain services that will fit your needs, and that contains a lot of complexity and that you have to develop. And the last part is about the blockchain itself, the Ethereum node that will operate, so mine your transaction, verify your transaction, hold your smart contract and your smart contract state. And basically this second step is a step that I've been implementing multiple times during my consultancy job. And it involves high cost of development, delay your time to production by months because you have to build them before starting to build your functional application. And finally, because there is some technical complexities inside, you of course have some more innovation and innovation risk when developing this intermediate layer. So basically, building an enterprise platform is quite long, and you will face some challenges. And we are here to go through your challenges and explain you a solution for each of these pain points. And hopefully that will ease your life when developing an enterprise application. So on this slide is an example architecture to give you some context and try to illustrate the later discussion. So on the top layer, you have the client services. So for example, in this use case, we'll use an asset issuance and redeem service that will try to issue some bonds or shares on the Ethereum network. So it will be connected to a user service, but also a KYC service to verify that the user are allowed to process to hold some shares. On the second layer, you will have what we call at PegaSys the transaction orchestration. So basically, the transaction orchestration is making sure that the transaction request that your asset service is emitting can properly be sent to the Ethereum node. So taking care of the signature of the transaction, of the nonce, of the gas issues. So this is the inbound flow to the Ethereum node. And then you have the outbound flow once the transaction is mined on the node. So making sure that the transaction is properly listened, decoded using the ABI of your smart contract, and potentially attaching the metadata that you have sent through the asset service at the beginning. So this transaction orchestration box, so we will deep dive into it later on, but it will be held by the smart contract registry, which is a registry of the contract that you have developed from the beginning of your, so when you started your application. So it will store the different version of every smart contract that you have used and be necessary to operate your transaction orchestration system. It will also be used. It will also be using the key manager, which is a component responsible for connecting to your key vault. So yeah, it can be a local key vault or a cloud-provided key vault. And then finally, at the layer 1 system, you have the Ethereum node itself. So for example, Hyperledger Besu is one of them. It will be held by the private transaction enclave. So you can, for example, Orion in that case. And this node will interact with every other nodes of the distributed ledger technology. So they may not have the same implementation. They may just be distributed application dApps or have the same kind of setup that you have. But so this is really the setup in your own infrastructure, in your own company. And yeah, so we will use this example architecture to illustrate what we are going to detail later. Do you have any question as an illustration?
Julien, we got our first question. Can you give some additional examples of asset services on layer 3 of the context architecture?
Yeah, so the asset service, for example, is so it can be an API that will So let's say you have a user that is putting a credit card into your asset service. You will go through, it will make sure that your user has been through its KYC process until the end. And at the end, it will try to send to your transaction orchestration system a request to issue some shares for this specific user, and we'll verify that, and we'll listen for the fact that the transaction has been properly mined from the transaction orchestration, and maybe send an email to the user saying that the shares have been properly issued. So it's really an example of service that would handle this kind of flow.
Great. Well, looks like we don't have any other questions, so you can keep going.
Okay, so moving on to the second section regarding the pain points and the requirements for enterprise application. So we will go through a list of the pain points that we have faced and the solution that we advise you to implement. So the first one is related to the security needs, and especially the private key issues the fact that you need to properly handle your private keys. So of course, private keys in a decentralized system is at the heart of your system, and you having a secure key vault is really essential, and you need you need at every cost to avoid your keys being leaked or compromised. So you have to put some specific security measures to make sure that they are secure. So for that, you will most likely be using a secure software that is dedicated to this kind of usage. So you may use a local key vault such as HashiCorp vaults. You may use a custody solution which is held by a third party, or a cloud provider. So for example, you have Azure Key Vault or AWS KMS that will hold the keys of either the company or the users that you have. And the complexity in this bit is that these secure software are quite complex and complex to master and to properly put into production. You have to properly configure and use rotating keys so that the key manager can, so this is access keys to the key vault itself. So you need to make sure that when your key vault tries to access to your, when your key manager tries to access your key vault, it will access it with keys, and you make sure that these access keys are properly rotated in case they are leaked. And you need to also make sure that if your transaction is asking for a signature of a specific account, you need to make sure that this account is allowed to access this specific account. So you have to put in place some permissioning for the users to make sure that they cannot access each other's key. But this is really the first element in the picture. Moving on to the second element in the private keys. So when trying to access your key manager, so the transaction orchestration is going to have a request asking for the signature of this transaction. And it will, so the easier setup is to have the key manager set up as an API, and the transaction orchestration will ask the key manager to sign this transaction, and then the key manager will continue the flow, try to sign it using your local key vault, for example. But this means that you will have some inbound request to your key manager, which is a bit insecure because the APIs are a bit more vulnerable in that setup. So what we recommend you to implement is to have an enterprise message bus that will be in between. And it's, instead of having the transaction orchestration pushing data to the key manager, it will push data to the message bus, and then the key manager will fetch data itself and you will not have some inbound requests to your key manager. So this is a bit, it's more secure, and that's what we recommend you to implement, especially in financial systems. And using this setup, you can properly isolate your key manager and local key vault in a dedicated environment, dedicated security network, in a Kubernetes cluster, for example. So let's move on to the second section of the security. So of course, you perfectly know that the smart contracts are processing your data, and that they will store your data and the data of your users. And you need to make sure that there is no bugs or vulnerability inside. So you need to make sure that they are properly audited every time they are used in your application. So this is why we recommend to have a smart contract registry, and your developer will push your smart contract to the smart contract registry. Then automatically you need to implement a process where your registry will ask a specific tool, an audit smart contract verification tool that will verify if your smart contract contains vulnerabilities inside, and make a proper automated audit of your smart contract before continuing your flow. You may also need some manual audit. So this is some information that you need to store into your smart contract registry. So storing your smart contract, but also storing the audit stage, and the audit report of that smart contract, and potentially the manual audit report. And once you have set up the proper rules for this, for the security rules, you can continue your steps and you can deploy your smart contract using the transaction orchestration. And later on, you can properly decode the logs of your smart contract registry and continue your flow properly. Before we move to the next item on the agenda, here are some commonly used terms that are necessary to understand what's next. So as reminders, the gas is kind of a currency that is similar to the Ethers on the public mainnet. And it's basically a fee that each and every account have to pay when sending a transaction. And this fee is sent to the miners or the validators of the block. The first state is a kind of service that is responsible for fueling your newly created accounts with gas, so that they are able to process your transaction afterwards, but also making sure that the accounts that are being used across your complete process are properly fueled at every time. Finally, the nonce is a counter that is inside every transaction, and basically when you send 1,000 transactions from one account, the nonce will be 1, and then 2, 3, 4, 5 till 1,000, and you need to sign this nonce, and yeah, so that it can be properly processed by the node itself. And finally, yeah, the transaction orchestration, as I've said, includes the gas management, the nonce attribution, to making sure you have the proper nonce for your transaction, the key signature and your access to the key vaults, and then listening and the decoding of the transaction. So with these terms, so yeah, we will move on to the no-fail environment section. So when you have your functional workflow, you need to, so failure is not an option. You need to make sure that if a transaction request is emitted by the asset, you have set up every services that are needed to process your transaction, and make sure that it will be mined in the end. So the first thing that you have to do is to properly fund every account that you create and every account that you use regularly. So for that, you need to set up a faucet inside your own infrastructure that have enough gas to fuel your accounts, and you need to put a kind of an alert if this faucet, if the amount of ether on this faucet falls below a specific threshold, so that you can fund the faucet, so that it can fund the accounts that you have. Second item, so this is especially true in public network. So the gas price is subject to the supply and demand mechanism. So as the supply is quite fixed, if there is an increase in the demand, the gas price can increase drastically. And if you've signed some transaction just before, your transaction may not be mined and will be pending in your network. And for that, you have to build another service that will track every transaction that you sent from your transaction orchestration, and making sure that if the gas price has increased a lot, it will take your transaction that has been broadcasted on the network, update the gas price with a higher value, and then resend it and rebroadcast it to the network. There is two other items that you need to take care of. This is also true for a public network. Even if you send a transaction to the network, it can be lost. For example, maybe your transaction has not been broadcasted to the proper validators, or maybe there is too many transactions on the network currently. So you have to, again, have a watcher that will keep track of your transaction until they are mined. And if they are not mined, try to rebroadcast your transaction to make sure that the validators get your transaction properly and can include it in a block. And in any case, you can have some unrecoverable failures. For example, if you don't have enough gas on your faucet, if you don't have the keys of this specific Ethereum account. So in any case, you will need to handle some errors on the application side. So you need to define some proper error codes into your transaction orchestration, so that your transaction that has happened in your transaction orchestration can properly flow back to your functional application. Finally, let's move on to the high volume requirements, which is the last section from the pain points. So when you want to design blockchain application, you of course want to avoid some critical performance issues that often appears quite quickly when you want to send batches of transaction. Because when you send a batch of transaction, you need to keep track of the nonce properly, the nonce of each transaction, and you need to assign the nonce of your batch of transaction properly to each transaction, and then you can send the batch to the node itself. So this is what we call the nonce management. So you need to store the nonce in a highly available distributed database that will hold the nonce of your accounts. And the other bit is that in some environments, you need really to keep the order of your transaction in the correct order. So when you have 1,000 transactions from the asset service, you need to send them in the same order to the node, even though the miners can switch the order. So that for that, you need to use the enterprise message bus that will properly store your transaction request and then process them sequentially and send them in the same order. And so this is for the inbound flow. And for the outbound flow, in the same way, when you listen to your block and when you go through every log and every transaction, every receipt in your block, you have to publish it in the same order and keep the orders of the transaction in the same way as they have been mined, and push it to your transaction to your functional service. So this concludes our second section. Do we have any question? Yes, I think we have.
We have quite a few, Julien. Starting with the first one we have, how do you proceed with a key when it's compromised and it is, for instance, the owner of an application smart contract? Should you use multi-ownable smart contracts as a good practice?
So this is really a smart contract-based practice. It really depends, I think, on the legal perspective of your. So first, on the legal perspective, in some case, especially for assets, you need to make sure that you cannot lose your assets. So in that case, you may have to build, multi-ownable smart contract. But yes, in any case, you will end up in a tricky situation, and maybe set up a multi-signature wallet where you split your keys into multiple store or vaults can be useful.
Great. Next question is, can you explain more how your faucet service works? Are you using ETH-gas pattern? How do you prevent fraud in your faucet service?
So the faucet service is really internal to the transaction orchestration, so it cannot be accessed externally. So there is no risk of fraud if your users. So basically, making sure that your users do not request too many transactions, and then the faucet will fuel them according to the rules that you have defined. So inside your faucet service, you can set up some cooldown. You can set up some cooldown or whitelisting, blacklisting mechanism. You can have a rate limit for a specific account or more general, or for the whole faucet. So it really depends on your needs. And of course, yes, you can use ETH-gas station, but not really for estimating the gas that the transaction are going to be used. So it's not really in the faucet, but it's more on the crafting or gas service.
Next one is, what is the mechanism behind the transaction knots? Especially how is the transaction knots managed across several nodes using the same account?
Yeah, so so basically for the nodes, so what you have to set up is a distributed database that is going to keep the nodes, the current nodes of every account on this database. You need to initialize it by fetching the proper nodes on the chain, and then when you have initialized it, you can start from these nodes. And if you receive 1,000 requests, you can properly increase it. And yeah, so this is important to have it on a consistent and distributed database, so that if you split your transaction orchestration into multiple components and that try to access the same data, it's really consistent, and you cannot have two transaction orchestration replicas that will access the same value incorrectly.
Great, good answer. Next one's from Mike. What examples do you have of recommended highly available distributed databases? Is this something like an IPFS?
So for the high availability, maybe we can answer this question later on, but because we will have a high availability section at the end. But yeah, okay. So for this specific bit, so you can just use a classical centralized database inside your application. So in our product, we are using Redis to use this. So this is really a kind of a cache mechanism that needs to be consistent and distributed. So we are using Redis.
Great, yeah, and we'll go into it more. Good point. Next one, regarding pre-funding accounts, do you recommend an open source service that can monitor the funding levels?
So no, I think this has to be done to be built inside your application, and basically you need to have a kind of faucet API that will, when you create an account, you need to check to fund it directly, and when you want to process a transaction, it will check the status, so the amount of gas on this account, and in order to continue the flow. So yeah, there is no really open source service. It's more, I think, something that has to be built custom.
Great. Next one. This one is, would you mind comparing it with Besu without the third-party signer? So I think maybe this relates to the private key stuff.
Yeah, yeah. So Besu is really the processor on the Ethereum node. So it's really the processor of your transaction, but it will not manage. So if you want to have multiple Besu nodes, for example, you need to take care of the nonce yourself, and you need to take care of managing the nonce in a centralized database. You need to take care of the key signature. So for example, using eSigner as a key manager, and yeah, so and you will need to build a smart contract registry that will properly decode your transaction. So it's an addition to Besu that is really complementary to Besu or to any Ethereum client.
Good point. Next one, and we'll probably take maybe three or four more, and then we'll move on. And I'm keeping a list, so anything we don't answer right now, we'll answer at the end. Next one, do you need to add a new role in the company organization, i.e. the key manager, in order to be compliant with company security policy? Who takes that role in your experience?
That's really depend on the needs that you have and the policies that you want to set up, and I think it's really specific to your use case. So yeah, it really depends on where you want to hold the authentication. It can be at the top level on the user APIs. It can be also on the key manager to verify, for example, that you have a proper GWT token and you are allowed to access this kind of key. So this is what we have implemented. And yeah, it really depends on the security that you need.
Yeah, that makes sense. How do you manage unrecoverable failures? For instance, in finance, it's unacceptable if the transaction does not settle. How do you mitigate this?
Yeah, so in that case, so it really depends on the problem that we are facing. So for example, so you cannot, there is really in some case a situation where you cannot recover the failure. So so your application, your functional application need to keep track of these errors. And for example, if the faucet hasn't the funds to send the gas to the account that is trying to make a transaction, you need to store this kind of error, send a proper email, send some alerting to say, I need some gas, and then pause the process and continue later on. And that's also true for any other kind of failure.
Okay, two more. Is the enterprise message bus part of the PegaSys Besu blockchain solution, or is it external? We'll probably get to this in a minute.
Yeah, we are, but so spoilers, we are using Apache Kafka as an enterprise message bus. So it's not part of the solution, but we are using it yeah, quite a lot. But basically you can plug any, if you already have a message bus, you can plug it, plug your own application, your own services on top of your enterprise bus.
Yep. And last one, can you share any stress test results? For example, transactions per second, for example, for an ERC20 token transaction.
Yeah.
So basically, I think
so on that if I'm correct, Besu, so it's really related to the throughput of your node itself. And I think that Besu has released some benchmark on that regard. So I can encourage you to look at these benchmarks. And on our side, we will try to run the same benchmark and publish the result really soon.
And we have a couple more, but we're going to punt those till the end if you all don't mind. So you can keep going, Julien. I just want to get through all the content.
Okay, so yeah, I'm pleased to introduce PegaSys Orchestrate, which is basically the transaction orchestration system that we have been building as a product inside PegaSys. And as I've said, it's really the middle layer of the services that are just in between your blockchain and your specific and functional use cases. So it's designed to be use case agnostic and will contain multiple features such as the transaction management, the private key storage, the smart contract registry, of course, the account management. It is completely client agnostic, so you can use a Chrome node, an Hyperledger Besu node, a Go Ethereum node, or a Parity. And it's also compatible with Orion and Tessera as private transaction managers. The goal for this is to give you some services that are ready to use from day one, so that you can build immediately your services with ease and robustly. It's also multi-chain, meaning that with one orchestrate, you can orchestrate your transaction through multiple chains. So for example, you can register a new chain in your PegaSys Orchestrate, and this chain will be the mainnet, for example, but you're also able to register a private chain. And basically, you can begin by creating some transaction on your private network, reach an agreement, and when it's done, you can publish something on the public chain. So the goal is really to be able to send transaction to one network or to another really easily, and it allows you to do some interoperability mechanism really easily. And of course, it's a software that you can deploy on-premise or on any cloud. So it has been tested on AWS and Azure, for example. And now we are going to deep dive a bit on the different features. So the first one really is the transaction manager. So starting by the transaction crafting, which is mainly what is inside Web3 libraries. You have also the gas management, so making proper requests to get the gas price and the gas that are going to be consumed by the transaction with some strategies. You have the nodes management that will be really useful to send batches of transaction to the chain, handling the signature of your transaction, sending your transaction to the network, and then potentially, if you have added some metadata to this transaction, for example, it belongs to Mr. John, you want to store it, and if your transaction is mined, you want to attach this metadata again and continue processing your transaction. So on this part, you need to listen to your transaction being mined. And when it's mined, get a receipt, and then decode the receipt, attach the metadata, and push it back to your functional application. So yeah. So why do you need a transaction orchestration manager? So it will remove a lot of complexity, initial complexity when trying to build your initial application on the network. It will help you with performance issues and will gather every dependency, blockchain dependency, into one single place. Where it's properly implemented and robustly implemented in a consistent way. Second deep dive is the contract registry. So it will hold your smart contract. It's not the same as a package manager on Ethereum. It's really a database that will store your smart contract, compile your bytecode, and then you will be able to deploy your newly pushed bytecode, and then be able to properly decode your transaction while still ensuring that you have kept the older version of your smart contract. So this is why we have, so you can upload ERC20 version 1.1, you can deploy your custom smart contract, etc. And inside it, you also need to make sure that, so you can configure your smart contract registry for it to call a smart contract verification tool such as Meetix to verify that there is no vulnerabilities inside your smart contract. Why do you need it? It will help you to get rid of the Web3 dependencies that you have to put into your functional application because it will decode the event for you, ensuring compatibility for your newly created smart contract, but also for the previous created smart contract. And it will also help you increase the security of your smart contract by performing some regular audits every time a code is pushed, or every time you have a major release, making a manual audit, a deeper audit. Third key element, the private key storage. So we have integration with HashiCorp Vault and Azure Key Vault. The goal is to, so we have implemented the design that we have recommended, of course, at the beginning. So we have a key manager that will fetch the transaction request from a message bus, and then have HashiCorp Vault sign your transaction for you in a completely isolated network and with protocol isolation. So it's really a setup that is necessary if you want to do some financial asset signature in a regulated environment. Fourth item, the multi-tenancy. So this is something that is quite new and will be part of the release that should come in the next days. So the goal of the multi-tenancy is, so if you're a service provider, a B2B service provider, you may have a specific chain for each and every company, and you may have sets of keys for each and every company. You want to make sure that the keys of the tenant A cannot be accessed by the tenant B, and you also want to make sure that the private state, the private blockchain state, so for example, the Orion of the tenant A cannot be accessed by the tenant B. So for that, we have in place the multi-tenancy that will make sure that the data are not mixed, and we enforce the authentication using JWT token and the Open ID Connect standard. So for that, so you will need to authenticate as the tenant A by having a JWT, and then when you are trying to access your keys, we will check the JWT. When you are trying to access the network, we are going to check the JWT to verify that you're properly authenticated and allowed to access this data. So it will help you to reduce the cost of your transaction manager, because you will have only one transaction orchestration tool that will handle many use cases or many companies. It will make sure that the data of multiple different legal entities are not mixed and are properly isolated from one another. And we'll also enforce the authentication until the end when trying to access the keys and trying to sign a transaction with a private key. And finally, the last item is the high availability. So we are using Postgres, Redis, and Kafka for high availability. And the way we have designed Orchestrate is that you can spin up multiple times the transaction orchestration components in multiple replicas, so that your you're always able to perform the transaction properly, even if a node crashes in your Kubernetes cluster. Yeah, and for that we are using, as I've said, the enterprise message bus to ensure that every transaction is kept in a queue and properly and not lost somewhere if a process dies. So it will help you to have resilience in case your node crashes, help you also with data loss because Postgres, Redis, and Kafka can be distributed across multiple nodes, and help you if you need some horizontal scaling. If you have, for example, many different chain, maybe your setup is to have 100 different networks, blockchain networks, and you need to scale to be able to handle the transaction and the flow on these 100 networks. So you need to have a proper way to scale your transaction orchestration. So this concludes the PegaSys Orchestrate presentation. So in terms of products, PegaSys Orchestrate is just above the Ethereum client. So in PegaSys, we have an Ethereum client, which is called Hyperledger Besu. We have PegaSys Plus, which is the enterprise edition that contains encryption at rest, advanced monitoring, and event streaming. Orion is is a private transaction enclave that is developed by PegaSys. And eSigner is a key manager that is used by PegaSys Orchestrate, and that stores the key in HashiCorp Vault or Azure Key Vault. And so, yeah, and PegaSys Orchestrate is really transaction orchestration and the smart contract registry that is needed to perform many operations. I conclude our talk. You can find resources on the website of PegaSys, and you can find the documentation of Orchestrate in the following link. Thank you very much for attending this session. We will move on to a Q&A session. You can find my email address over there, and please, yeah. You can send a feedback. You can fill the feedback form that is on this link, and don't hesitate to reach out to us for any question at PegaSysInfo@consensus.net. Let's go for Q&A.
Yeah. Yep. So we'll dive into the questions that haven't been answered just yet and keep asking them in the chat. First one. So I'll ask this one in two parts. Is PegaSys Orchestrate able to connect to other Ethereum-based blockchain networks, such as Energy Web Foundation? Part two is, are there any requirements on consensus mechanisms?
Yep. So it's really completely agnostic from your node. So there is no really overlap between Orchestrate and your node. So your node can work with any consensus algorithm. There is no really issues. And the only thing that we ask is that your Ethereum node implement the standard Web3 interfaces. If I'm not doing any mistake, the Energy Web Foundation is using Parity, which implements, of course, the Web3 standard. So we would be able to connect to this kind of blockchain network.
Yep.
And happy to try it out.
Yeah. Next question. Does this mean you'd be able to set the smart contracts to transfer keys to another pre-identified person without a third party?
Yeah, I don't really understand the context of the question. So it really depends on your use case. The keys will be stored in your vault, and yeah, maybe having more context around this question could be useful.
Yeah, that's fair. Next one. Do you have versioning, for example, full tokens won't work with smart contracts. Currently, we have to mint equivalent amount of new tokens or business logic smart contract upgrades. So yeah, just talking about versioning.
Yeah, so we do not we do not implement ourselves the upgrade pattern that you can find on OpenZeppelin, for example, because it's really depending on your use case. The thing that we make sure is that the ABIs that you have uploaded, the bytecode, the smart contract code that you have uploaded can be, so we keep track of this code, and we allow you to deploy the latest version, a previous version, and at any time you will be able to decode the logs and the transaction of your previously deployed smart contract, even if it's 1 year, it was 1 year ago.
And then Brent had a question. You mentioned gas and a fee for mining tokens. Can you mine your own tokens on a private node site?
On a private node, sorry. Okay, can you repeat?
Private node site. So I'll repeat. Yep. You mentioned gas and a fee for mining tokens. Can you mine your own tokens on a private node? It says private node site, but it just might be private node.
So
here, let me.
Yeah, I'm
Brent,
not sure.
Yeah, I'm not sure we understand the question. Brent, do you mind expanding a little on the comments? The other question we had that's also, we'll answer another question. I'll clarify that if you don't mind, is asking about gas as well. So Besu has no gas cost, correct? And what does Besu not have that the main chain has? Basically, are there any downsides to Hyperledger Besu? So this is a little different than Orchestrate questions.
Yeah, so Besu can work on the mainnet. So it's compatible with any feature that you need on the mainnet. So you can set up a gas inside. You can use Besu with the mainnet because it implements properly the gas mechanism. You can set up a private network that has a proper gas mechanism too. So it's really up to you to when you set up the network to use the gas policy that you want. So we do not enforce gas price to be zero. So yeah, basically the best you could hope for a client. So it's both working on public networks and private networks.
That's the last question we have, unless we get some clarification on that other one. Any other questions from the audience? And as a reminder, please fill out the feedback form. We really appreciate it. Here we go. When do you expect the PegaSys Orchestrate documentation to be complete?
Yeah, so currently the PegaSys Orchestrate documentation is complete for the version 1. We are releasing the version 2 really shortly, so there will be some modification really shortly. So in a few weeks, it will be ready.
A couple more coming in. Can you configure Hyperledger Besu to work with Ethereum mainnet? Alternatively, can you configure Geth to work with PegaSys Orchestrate?
Yes.
The answer is both to all of them.
Yep. Yes. So you can use Besu to connect to your Ethereum client, to the Ethereum mainnet. And also you can, as PegaSys Orchestrate is completely agnostic to the client, Ethereum client you are using, it can be connected to Geth and yeah.
Great. And one more, this is probably a good one to end on. Can you share an industry use case where you implemented what you just presented?
Which it's really pieces were taken from every use case, so it really depends. For example, the no-fail environment came from financial institution that wanted to execute a trade. Someone was telling them to execute a trade, and they had to process it, and they shouldn't. They couldn't say that something is broken or or we have an issue. So they had to perform the transaction properly until the end. So this is where you have to set up this kind of things.
It's probably worth saying Covantis is an example that's using PegaSys Orchestrate.
Yep.
You want to talk about Covantis and their use case just from a high level?
Yep. So Covantis is a really big consortium of trade finance companies, and so we have. So they are using PegaSys Orchestrate to handle the flow and the private transaction and the transaction on their network. So this is one of our big customers. And you may find some articles online on Covantis.
Yep. And then I think Tom had one follow-up question about, so we said that basically Besu runs on mainnet and Orchestrate runs with Geth. What would you recommend with each of them though? So Besu, it doesn't matter. You can run it in permissioned or mainnet settings. There's no preference. It depends on the use case. If you want to use it for a permission setting or a mainnet use case, that's very use case dependent. For Orchestrate, I'll let you answer.
So again, it really depends on your use case, and the gas strategy has to be, so we recommend to use the gas every time because it's a key part of the design of Ethereum and help you avoid DDoS attack and everything is working with the gas. So that's something that you have to, we recommend to implement it and not to set the gas price to 0, except if it's for test network on your own side.
Looks like that's the last question. Mohammed, if you wanted the licensing agreement, you could reach out to PegaSysInfo@consensus.net or Julien or my email.
Yeah, sure.
Great. Any last questions? Last call? Great questions, everyone. Thanks for everyone's time.
Thank you, everyone.
Great. Thank you. Great job, Julien. I will stop the recording now.